chemical change, and we are looking at the effect of heat on the what? On the matter. As we proceed, I'll be giving you the graphical description. I'll give you the graphical description of what heat could do to any particular body. Now, number one, chemical change. Chemical change, e.g., as we are talking about vibration of molecules of a body, either gas, liquid, or solid. It can make the what? I was talking about atoms of molecules. The atoms of molecules that constitute a body can tend to what? Change their position when heat is involved. Let's take for instance, a rubber bucket. A layman will say this is a rubber bucket. Abi, but a scientist or an engineer will not say this is a, but we call it what? A solid polymer. This is a solid polymer, or PVC, polyvinyl chloride. Now, if you do chemistry, you'll be taught all this. Now, if you have a solid polymer here, it's a plastic. Do you understand? Now, if this plastic is subjected to heat, before heat is being incident on this plastic, it has a, how do I put it? It has a stable molecular structure. These molecules or structure that forms this plastic is what? Static. It's being bound by what? Very good intermolecular forces. That is why the bucket retains its structure. But immediately heat is being incident on it. What happens? Those molecules of intermolecular forces, those molecules that is being formed by different intermolecular forces tends to vibrate. Now, immediately it tends to vibrate, it means that the heat is actually breaking those bonds. Do you understand? It's breaking the forces. What do I mean by breaking the forces? The force that is, let's say this is atom A, this is atom B, there is a force holding them together. Now, this particular force is very strong, but at the effect of heat, what happens? This force is being what? Broken down. So immediately a particular what? Force holding atom A and B is being broken down. All the molecule, atoms of molecule in this bucket tends to what? Start to vibrate. Immediately it tends to vibrate, what happens to the bucket? It melts. So immediately the bucket melts, you know that heat has what? Changed the structure of this plastic bucket. That is one good effect of heat. Another effect of heat on matter. Another effect of heat on matter is what we call physical change. When you say physical change, I was making reference to a scenario where a bucket is actually being undergoing melting. Now, when a bucket melts, it means that the intermolecular forces, the forces that are actually holding the what? Molecules, atoms of molecule of that bucket is being broken by that heat. So maybe those forces are being broken, those particles will tend to what? Start to move, start to vibrate. When they vibrate, it means that that bucket is melting. Now, considering the physical change I'm about to talk about now, the physical change. First, what will happen? First, there will be a what? A chemical change. Immediately there is chemical change. That's in the internal structure of your bucket. If this is to be the bucket. Do you understand? What will first happen is the internal change. And that internal change is your what? Is your chemical change. Where you have movement, when you have rough movement of the what? Atoms of molecules. The atoms of molecules that what? That make this bucket to be rigid. So immediately you have a change in the what? In their structure. But if they start moving around, then you now have, that's your chemical change. Then you now have the physical change. Like what? Like physical change like what? Like physical deformation. Physical deformation. What do you mean by physical deformation? You can see the structure of this bucket is cylindrical. Abi, this is cylindrical. If this bucket starts to melt now, it might turn to something like this, shapeless. It might turn to something like this, flat. So any structure which it tends to turn to, it means that that particular body will undergo physical deformation. That's one funny effect of what? Heat on any matter. Another effect is temperature change. Temperature change. Now, one thing you should notice is that all these properties that is being listed, Number one, we spoke about chemical change, whereby the internal structure tends to what? Change position. I mean, the internal molecular atom tend to change position. The next one we spoke about is what? Your physical change, where you have the real shapeless structure. Now, the third one is your what? Change in temperature. What you should notice is that all these properties might what? Be occurring at one particular what? Scenario, as in at one particular what? Occurrence. That is, just one body, 3 things or 4 things are taking place simultaneously in the what? Actual what? Incidence of heat on this particular body. It's the change in temperature. Why? Because before you place this bucket to be incidented by what? Heat. Let's say the temperature of that bucket is, let's say, 50 degrees Celsius. 50 is still hot. Okay, let me bring it down to 20 degrees Celsius. It has a stable what? Temperature content. Now, maybe you subjected it to heat. It starts to melt. Let's say it melts at 80 degrees Celsius. And by the time it what? Becomes flaccid here, the temperature has risen to maybe 100 degrees Celsius. So at this junction, you have realized that a temperature from 20 to 80 now to 100, it means that heat has brought about change in what? In temperature. That's another what? Effect of what? Your heat. Another one is what? Change in pressure. Change in pressure. When I talk about pressure of a body, heat can what? Ignite the pressure of a body. How do you analyze this? Let's do it this way. The bottle of your Coca-Cola. This is your Coca-Cola here. Now, you bought it. You've not opened it at all. You've not opened. Right? Now, despite the fact that each of your Coca-Cola bottle is what we call Coca-Cola. It's a soft drink, right? Now, this Coca-Cola bottle is being carbonated. That's what we call carbonation. It's being carbonated by CO2. What do you mean by carbonation? Or something being carbonated? Carbonated is actually means injection or infusion of what? Enough gas. Those are the gases that makes you what? Feel like belching. Or feel like each time you want to take Coca-Cola, each time you open it, it begins to foam. It foams out and it wants to what? Pour out of the bottle. It is due to what? This carbonated characteristics that is being what? Infused in this your particular bottle. Now, this bottle has been carbonated already. So then definitely it has higher tendency of what? Increase in pressure. What is pressure? Pressure is just a phenomenon whereby some particular what? Constituent in a particular what? Structure tends to what? Outdo due to some kind of what? Internal effect of what? Internal practices of what? Force. Those force tends to what? Make those what? Internal properties to tend to outdo what they are initially what? Placed for. What do I mean? The internal carbonation is there. Do you understand? Now, you now subject this of Coca-Cola to heat. You can practicalize it. You place it on a hot water. You place it in a pot. Let's say your pot is surrounding it. Do you understand? Now, this your pot is being heated. Do you understand? You place it on a hot fire, and this pot tends to what? Boil. Now, if this particular Coca-Cola's temperature tends to rise, the cork here can blow off. Why? Because the heat here is increasing the pressure of the content of this your Coca-Cola bottle. And before you know it, what happens? The cork flew off. Or the cork will fly off. Now, immediately the cork flies off. It means that what? The pressure has what? Increased. So immediately the heat is being incident on the bottle of your Coca-Cola drink. You realize that apart from the carbonation of this particular content, do you understand, of this particular bottle, it means that this CO2 will definitely you always definitely subject this bottle to higher work pressure, irrespective of anything. You know, before you place it in your hot container, even if you shake it up, there's tendency for what? The content to foam out. But the pressure of that foaming cannot open the cork. But maybe this container the bottle is not being placed or being subjected on heat. The pressure that will come out of this bottle will remove the cork. You can try it. It is something that has been tried and what? Confirmed. So that's the fourth word. effects of heat on matter. So let's look at some graphical notation or graphical description of what? Heat on what? Matter. Now, based on what you have there, you could see what we have. We have the arrangement of molecular what? The arrangement of atoms or molecules of a particular solid body. Now, if this is to be the solid body, this is the what? Molecular structure. It is well arranged. It has strong what? Intermolecular forces. Now, if it's actually being is undergoing melting, heat is being subjected to heat. If it's being subjected to heat, you understand? It becomes to have what we call a structure where we have free movement of those atoms or molecules. You understand? So from there you start to realize that the strength or the structure of this particular body, which is solid, will tend to start what? Changing. That structure can now change from solid to what? Liquid. At the point where the particular what? Arrangement of atoms or molecules tends to become liquid, it means that the what? Arrangement of atoms or molecules is now what? Initially they have fixed and strong intermolecular forces held them. That is why they are solid. Now, immediately there is now free movement of those atoms. It means that the actual physical structure is now what? Becoming soft. That is soft. So this is solid and this is liquid. So from your graph, you get representation there. Anything further from it, it will turn to your what? Your gas. So those are just the explanation as regards the effect of heat on matter. So let's go straight into temperature. Now for your temperature, we are looking at heat energy. Now, whenever you talk about heat energy, you have to talk about a lot of things that are associated to it. Now, as regards temperature, first, what do you need to know about temperature? You need to know about the actual definition of temperature, and definitely you also need to look at the parameters or the tools used to measure your temperature. Now, apart from that, we also look at the thermometric substance. When I say thermometric substance, those substances that are occupying those tools, they are used to measure temperature, and those substances